This is the Hubble telescope, a photo that has just been sent back. After scientists finished looking at it, they collectively fell silent. Inside this photo are hidden 200 million stars. Every single one is dozens of times bigger than the Sun, and all of them come from the Andromeda Galaxy that is 2.5 million light-years away from us. Even more terrifying is that this galaxy is charging toward Earth at a speed of 110 kilometers per second, and 4 billion years later, it will collide head-on with the Milky Way. But you absolutely cannot imagine that the Andromeda Galaxy had actually already been covered in wounds long ago. Scientists found, on it, two gigantic dust rings, like ripples in a pond. This means it had once been struck viciously. Who was the murderer? Actually, it is the dwarf galaxy M32 that is still hanging beside it right now. That brutal collision 200 million years ago almost tore the Andromeda Galaxy into two halves. And even earlier than that, there was also one giant galaxy whose mass is equivalent to 25 billion suns. M32P was directly swallowed by the Andromeda Galaxy, creating 1/5 of its stars as it is now. How many neighbors has this violent galactic giant beast eaten before? When it crashes into us, does the Milky Way still have a chance to stay alive? The history of humans observing the Andromeda Galaxy has already lasted for 1,000 years. In year 964 AD, the Persian astronomer Abd al-Rahman first discovered it, and at that time described it as a blurry and unclear nebula. Until nearly 700 years later, on 1612 year, 10, 2-month, 15-day, Simon Marius became the first person to observe it through a telescope, and only then did we truly see clearly what it looked like. As time went on, more details of this blurry nebula gradually surfaced. In 1764, Charles Messier officially named it M31. But the most important breakthrough happened a century later. The third-generation Earl of Rosse, William Parsons, this amateur astronomer, full of passion yet with a strange personality, built, in the garden of Bere Castle in Ireland, a gigantic 72-inch Parsonstown Leviathan telescope. For as long as 70 years, it had always been the largest telescope in the world, a one and only existence. Parsons used this giant telescope to observe the spiral structure of the M51 nebula, which is the whirlpool galaxy we are familiar with. This was the first time humans discovered a spiral structure inside a nebula. This major discovery instantly ignited astronomers' enthusiasm for exploration. Afterwards, the British amateur astronomer Isaac Roberts, in 1888, photographed the first Andromeda Galaxy photo in history, clearly showing the iconic spiral structure. Even with photographic evidence, scientists still could not determine what exactly the Andromeda Galaxy is. They grouped it together with thousands of other spiral nebulae. These nebulae have a common characteristic. Their way of motion is completely different from other stars in the night sky. This triggered fierce debate among astronomers at the end of the 19th century. Are spiral nebulae a part of the Milky Way, or do there exist other independent universes similar to the Milky Way? In 1925, Edwin Hubble successfully cracked this mystery. Hubble, in the Andromeda Nebula, discovered two variable stars called standard candles. The periods and luminosities of this type of star have a clear correlation and can be used to measure the distance between galaxies. After calculation, these two variable stars are about 1 million light-years from Earth, far exceeding the then lonely Milky Way, whose diameter at that time did not exceed 300,000 light-years. With this major discovery, Hubble powerfully proved that the Andromeda Nebula is an independent galaxy. The mysterious veil of the vast universe was lifted by one corner from then on. Our cosmic neighbor, the Andromeda Galaxy, was officially confirmed. It can be said that the Andromeda Galaxy can help us understand the way galaxies operate even more than the Milky Way. Studying the Milky Way structure is extremely challenging. We are inside it. Many factors interfere with observation. Interstellar dust scatters light, making celestial bodies look redder than they actually are. Accurately measuring distance is extremely difficult, and various kinds of noise in the foreground will also block key details. And the Andromeda Galaxy M31 almost does not have these problems. It is about 2.5 million light-years away from us and is an ideal natural laboratory for studying galaxy formation and evolution. But to make full use of this laboratory, ultra-high-definition observation images are needed. Whether professional astronomers or amateur enthusiasts, all have observed the Andromeda Galaxy using ground-based and space telescopes from different angles, with different resolutions and wavelengths. But the image released by the Hubble Space Telescope on 2025-year 1-month 16-day made all previous observations look dull by comparison. After 10 years of continuous observation, the Hubble telescope synthesized the largest photomosaic map so far. This image spans more than 1,000 orbital runs, integrates more than 600 independent photos, has a total pixel count as high as 2.5 billion, and presents the clearest and most complete full view of the Andromeda Galaxy we have ever seen in history. Let us admire this masterpiece together. The image presents it from an almost side-view angle. The Andromeda Galaxy is tilted by 77 degrees relative to Earth's observing angle. The right side is the northern region, and the left side is the southern region. Astronomers speculate that the Andromeda Galaxy may have as many as 1 trillion stars, but most stars have extremely low brightness. Even as powerful as the Hubble telescope, it cannot detect them. Even so, this image can still distinguish 200 million stars, becoming the clearest galaxy image in the universe so far. Through detailed observation of this near neighbor, scientists are able to reveal more about its history, its differences from the Milky Way, and its future evolutionary direction. We know that the Andromeda Galaxy is a whirlpool spiral galaxy with a diameter of about 150,000 light-years and has spiral arms extending outward from the core. Even so, many of its features are still extremely unique, and this new image finally lets us begin to understand the reasons inside. This image was taken in 2015. It is an important achievement of the Hubble Panchromatic Andromeda Galaxy Observing Program, and it can be highly magnified to present astonishing details. The Hubble telescope spent more than 3 years taking pictures of 1/3 of Andromeda Galaxy's star formation disk. The image coverage runs from ultraviolet to near-infrared across 6 complete spectral bands. Carefully observe the outer edge of the image, and you can see an elliptical star formation ring, about 10 kiloparsecs from the galaxy center. These newborn stars are bluer than other surrounding stars, have higher temperatures, and are rich in metal elements, and contain chemical elements heavier than helium or hydrogen. The higher the magnification, the more stars appear, and the number is astonishingly large. Hubble team researchers said these stars look like densely packed grains of sand on a beach, showing how high the image resolution is. This star formation ring made astronomers puzzled, but this is not the only mystery. In 2006, researchers used the Spitzer Space Telescope's infrared array camera and discovered a second dust ring. It is located near the center of the Andromeda Galaxy, at about 0.5 kiloparsecs, and had long been hidden in our field of view. At first, scientists thought it was a miniature spiral structure related to a dense region where stellar orbits overlap. The existence of the 2 rings is absolutely not accidental. But where did they come from? These ring-shaped objects are about to uncover the Andromeda Galaxy's sealed past. For decades, scientists continuously studied this galaxy, yet there was little evidence showing it had suffered a violent collision. But these ring-shaped objects tell a completely different story. Just as the astronomer, the 2006 research author David Block said, "These dust rings are like ripples in a pond, and ripples must originate from an impact." That's right. Scientists ultimately concluded that these ring-shaped objects are the remnants left behind after the Andromeda Galaxy collided with some half-galaxy dwarf galaxy. About 210 million years ago, the Andromeda Galaxy collided with a half-galaxy, like a rock falling into a calm pond. This impact produced a powerful dust shockwave. The shockwave passed through the galaxy disk and left behind 2 ghost-like traces that we can still observe today. Block and colleagues locked the culprit of this impact as the dwarf galaxy Messier 32, M32. Today, Messier 32 looks like a bright, blurry nebula and is only 5,000 parsecs from the Andromeda Galaxy's center. Through numerical simulation to recreate the impact process, researchers found that the head-on impact shockwave, triggered by Messier 32, successfully reproduced the ring structures we see today. That obvious hole on the outer ring is a unique feature formed when it interwove with the Andromeda Galaxy's spiral, and the simulation experiment even precisely replicated this detail. Since this discovery in 2006, many people believed we had already figured out the severity of the wounds suffered by our Milky Way neighbor. But thanks to the Hubble telescope's continuous observation, the Andromeda Galaxy is about to reveal to us more secrets unknown to us. The Andromeda Galaxy image taken in 2025 is the result of the Hubble telescope and the Fast Sky-Seeking telescope fast working together. This survey is an extension of the original plan, specially focusing on the southern region of the Andromeda Galaxy. The observing time lasted from 2021 to 2024. The Fast Sky-Seeking telescope added, in this census, observational data of 90 million stars, expanding the observing range to cover 2/3 of the galaxy's star formation disk. The reason to carry out this special survey centered on the south is because people gradually discovered that the polar regions of the Andromeda Galaxy are completely different from other regions. The southern region is more turbulent and restless than the northern region, carrying more key evidence about the Andromeda Galaxy's violent history and also retaining a large amount of battle traces. Because the light is too dim, these traces are difficult to identify in Hubble images, but the Andromeda Galaxy's southern giant stellar stream GSS is a highly recognizable huge feature. It extends from the galaxy's southern disk to the galaxy halo, spanning about 150 kiloparsecs. You can imagine it as a fragment stream formed from some galaxy whose stars were stripped away by Andromeda Galaxy's gravity. The giant stellar stream GS dead belongs to an unnumbered, scattered structure. The stars inside have extremely low temperatures and almost contain no gas components. Although their running trajectories are controlled by gravity, they will not radiate heat, and they will not collide with other stars in the stellar stream, like a group of marbles rolling along their own independent frictionless orbits. The giant stellar stream GSS, Messier 32, M32, and the inner halo are the three most significant metal-rich features in the Andromeda Galaxy. Some astronomers believe that their consistent metal wind degree indicates they all are the products of another major collision in Andromeda Galaxy's history, and the scale of this collision far exceeds the one that formed the star rings. And this event has a protagonist we are familiar with. A 2018 study tried to look for the truth of this larger-scale collision, and the result again focused attention on Messier 32. M32, more precisely, on Messier 32's ancestor, M32P. Cosmological simulations show that the most likely victim of the Andromeda Galaxy is the early version of Messier 32, M32P. At its peak period, this ancient galaxy, rich in metal elements, had a mass equivalent to 25 billion suns, and merged with the Andromeda Galaxy between 5 billion and 2 billion years ago. Its gas was sucked away by the Andromeda Galaxy's stronger gravity, triggering explosive star formation, creating about 1/5 of the Andromeda Galaxy's total number of stars today. Now we have a deeper understanding of this Milky Way neighbor. More importantly, we can roughly distinguish which stars belong to the Andromeda Galaxy. The Andromeda Galaxy has tens of billions of intermediate-age stars. For many years, astronomers have tried to explain this phenomenon. They originally expected that the Andromeda Galaxy's stellar composition would be more like the Milky Way galaxy. The halo and bulge are gathering zones of elderly stars, while the disk contains younger stars. However, if these intermediate-age stars were formed during the merger with the M32P batch galaxy, then we have finally found the answer. This also confirms the source of the Andromeda Galaxy's second wave of star formation. To get more strong evidence, one only needs to examine the new Messier 32 M32 galaxy image taken by the Hubble telescope. If the above theory holds, then what we see today is precisely the core part of the M32P galaxy after being stripped away. This description matches the observational results highly. In the center of the Messier 32 galaxy, there exists a relatively low-mass black hole with mass between 1.8 million and 5 million solar masses. Astronomers can use this data to infer the size of the central bulge of the M32P galaxy before it merged with the Andromeda Galaxy. The calculated results show that the central bulge of the M32P galaxy is extremely small. This also explains why, during the merger process, it did not completely sink into the Andromeda Galaxy's center, but instead allowed the stripped core to survive at the galaxy edge up to now. As mentioned earlier, this is still only a theoretical hypothesis, but it seems to be able to answer many questions about the Andromeda Galaxy's bumpy history and tightly connects several of its most unique features. But matters may be more complex. Around the Andromeda Galaxy there orbit 36 different dwarf galaxies. Any one may have affected it. These galaxies in the past may all have had interactions with it. Thanks to the Hubble telescope, we can now observe this neighbor with ultra-high resolution and begin to search for the traces of small-scale interactions between it and its satellite galaxies. No one can predict what astonishing secrets we will still discover. But this is not only about the past. This spectacular image can also reveal to us the mysteries of the future, as the two largest gravitationally bound members of the local group, the Andromeda Galaxy and the Milky Way, have always been considered the most likely candidates to collide. According to the estimated data of 2012, the Andromeda Galaxy is approaching the Milky Way at a speed of 110 kilometers per second and may collide in about 4 billion years. Of course, this perhaps is not a direct threat that humans need to face head-on. But if the collision really happens, what changes will these two beloved galaxies undergo? It is indeed curious. However, before you begin to imagine the appearance of the Milky Way collision instrument Milky, it needs to be emphasized that this is still a topic full of controversy. Thanks to the Hubble telescope's new image, we have reason to believe that the Milky Way may possibly get lucky and continue avoiding the destiny of complete destruction. In a paper published this year, University of Helsinki's Tilsawa and his colleagues used the Andromeda Galaxy data observed by the Hubble telescope to optimize the local group model. Specifically, the Hubble Panchromatic Andromeda Galaxy Observing Plan Fight Sky-Seeking measured the distances of 55 Saides objects inside the Andromeda Galaxy. These data, combined with orbital data of other local group galaxies, such as the Large Magellanic Cloud, indicate that the Milky Way's fate is far more uncertain than imagined. Within the next tens of billions of years, the probability of merging with the Andromeda Galaxy is only 50%. Predicting the Milky Way shower's changes after tens of billions of years is absolutely not easy. But now we can clearly observe the Andromeda Galaxy's current state, which will undoubtedly make prediction work relatively easier. The Hubble Panchromatic Andromeda Galaxy Observing Plan, FITE, and the Fast Sky-Seeking Telescope FAST. 10 years of effort has successfully come to an end, but related scientific research work has not stopped because of this. The details of this image are rich enough to cover 75 blocks of 8 Kelvin ultra-high definition screens. Scientists are still continuously digging for the hidden secret clues inside. This is only a microcosm of the endless cosmic exploration journey. The Hubble telescope may, for the time being, have shifted its observation focus to other targets, but this June, the Chandra X-ray Observatory released more related images, showing, with unprecedented detail, the supermassive black hole of the Andromeda Galaxy. As each observation continuously adds new details, in the coming years, the story of the Andromeda Galaxy will become increasingly complete. For now, this is undoubtedly a story full of anticipation. I cannot wait to witness the Hubble scientists' next new discoveries.